This video will show you how to make a Scheil solidification simulation for an aluminum-silicon alloy. In a Scheil solidification simulation, one assumes zero diffusion in the solidified material and infinitely fast diffusion in the liquid. So this example follows these assumptions. This video is based on example number 8 of the examples included with your software. Starting with ThermoCalc 2017A, you can now access the examples from within the software in both the File and Help menus. To begin the example, click on the Scheil solidification simulation template from the home screen of ThermoCalc. All the nodes we need will appear in the project pane. Select the AL Demo database and the elements aluminum and silicon. Set silicon to 1 mass%, which automatically sets aluminum to 99%. Next, select the Scheil calculator node. We will accept the default values, so make sure all your values match mine. Our simulation is set up, so click Perform Tree at the bottom center of the program. Once the calculation is complete, a plot will appear in the results pane. Note that results may vary slightly with different versions of the software. So if your plot looks the same as mine, but has slightly different values from the ones I mention, it is probably still correct. In this plot, the solid line represents the Scheil solidification simulation, which is a non-equilibrium solidification. It tells you at what temperature various phases solidify from liquid. If we zoom in at the beginning of the line, we can see that the solidification begins at around 655 degrees. By looking at the key, we can see that the first phase to form is FCC-A1. If we zoom out and follow the line until it changes colors, we can see that diamond, also known as C15 Lovs phase, begins forming at around 577 degrees. The dotted line represents equilibrium solidification. At the beginning, the two lines overlap, meaning that there is no segregation. Below about 652 degrees, the two lines diverge, which means that segregation is occurring in the alloy. The x-axis shows the total fraction of solids from all phases at each temperature. For instance, the rightmost end of the graph is entirely solid, and the leftmost side of the graph is entirely liquid. If you hover your mouse anywhere on the line, you will also see this information. For example, we can see that at about 650 degrees, the mole fraction of solid is approximately 0.44, or about 44%. You can also export data from the diagram. Right-click on the Scheil calculator node, hover over Create New Successor, and select Table Renderer. Right-click on the table renderer and select Perform Now. Your table will appear in the results pane alongside the plot. The table contains the same information as the plot. To export this data, simply click on the Save Table button found in the configuration window and select the format you prefer. You can also calculate other properties. Click on the Plot Renderer node, then select the axis variable you want to look at, such as composition of a phase, latent heat, molar volume, and density. Then click Perform again, and your plot will appear in the results pane. We hope you found this video helpful. We're constantly working to create new videos, so check back regularly at www.thermocalc.com.